Hi students, now we are going to discuss about disaccharides. Disaccharides. The disaccharides is a simple subtopic in carbohydrates. In carbohydrates lesson consists of number of subtopics are there. Among the number of subtopics, disaccharides are smallest individual topics. Now we are going to discuss about disaccharides. What is meaning of disaccharides? Disaccharides are sugar. It yields two monosaccharides when on hydrolysis. Hydrolyzed by using dilute acid or enzymes. In the dilute acid can be obtained from the mineral acid, organic acid, or especially mineral acids are used. Enzymes can be obtained from the organic synthesis substance. In the disaccharides molecule, maximum is a composition of two monosaccharides linked through glycosidic linkage or oxide bridge or ether linkage. Disaccharides general formula CnH2O n-1. CnH2O n-1. It is a general formula of disaccharides. The disaccharides topic or disaccharides compound consists of two monosaccharides. That compound can be formed by combination of in the two monosaccharides through single oxide bridge or glycosidic linkage. That compound or the bond formed between the two monosaccharides. Between the two monosaccharides, one monosaccharides contain anomeric carbon, that means called functional group carbon, can be combined with or react with another compound contain hydroxyl group. First compound contain anomeric carbon or functional group carbon can be combined with second compound contain hydroxyl group. For example, sucrose. Sucrose is a most important, most abundant disaccharides. Lactose, that means called milk sugar. It is the one important disaccharides. Another one, milk, then what? Maltose. The maltose can be obtained from the milk sugar. These are three compounds for example of disaccharides. Now we are going to discuss about what is the structure of disaccharides. In disaccharides contain one alpha D glucose molecule can be combined with beta D fructose molecules. In lactose, which contain 2 moles of monosaccharides. 1 moles of monosaccharide is beta galactose. 2 moles of monosaccharide is then beta glucose. In the last disaccharides, in then what? Maltose. Maltose, which contain 2 monosaccharides, both are same molecule of alpha D glucose. What is the formula of alpha D glucose? In the alpha D glucose exists as a pyranose form. Pyron ring, pyranose form. Oxygen, in then hydrogen, OH, in then OH, hydrogen, bond, OH, H, bond, OH, H, bond, in then hydrogen, then CH2OH. It is alpha D pyranose, alpha D glucopyranose. That alpha D glucopyranose can be combined with furanose form of beta D fructofuranose. Alpha D glucopyranose. OH, H, OH, H, OH, H, and then it is a CH2OH, H, CH2OH. It is a beta D fructofuranose. So alpha D glucopyranose can be combined with beta D fructofuranose along with the removal of water molecule, H2O. That OH group places in second carbon. The CH is the first carbon. Then next carbon is the second carbon is C carbon. Here the OH group bonded with the first anomeric carbon. The second carbon, the third carbon, fourth carbon, fifth carbon, sixth carbon. First carbon contain OH group of anomeric hydroxyl group can be combined with the second carbon contain OH group of keto group to form of sucrose of The sucrose compound can be obtained between two monosaccharides. Hydrogen in the OH, H, bond, OH, H, bond, OH, H, bond. In the hydrogen here CH2OH group. CH2OH. Next one, furanose form. Then hydrogen CH2OH, OH, H, here OH, H, then form of oxide bridge. It is a CH2OH, OO. It is oxide bridge. The oxide bridge otherwise called glycosidic linkage. Glycosidic linkage or oxide bridge or ethyl linkage, same meaning. The glycosidic linkage, oxide bridge or ethyl linkage can be formed between two monosaccharides. One is a alpha D glucopyranose, another one beta D fructofuranose. So alpha D glucopyranose can be combined with the beta D fructofuranose through oxide bridge or glycosidic linkage or ethyl linkage, means to form of sucrose. It is the structure of sucrose. Sucrose. So the sucrose molecule can be formed between the two monosaccharides. The sucrose molecule, it is the most abundant disaccharides. The sucrose molecule commonly called table sugar. The sucrose molecule found in the juice of sugar cane and sugar beets. In addition to that, the sucrose molecule found in the insect success in the honeybee. In the honeybee, which produce the one enzyme that is called invertase. That invertase it is used to in the decompose or hydrolysis the sucrose into glucose and fructose. So, in the honey which contain primarily consists of glucose, fructose and sucrose. The sucrose molecule, in the meta rotation of sucrose molecule is plus 66.6 degree. Meta rotation. That means called a article rotation. Article rotation of glucose is or sucrose is plus 66.6 degree. Then in the meta rotation of glucose is plus 52.5 degree. Plus 52.5 degree. Because of the positive sign indicate the both substance. What substance? Sucrose and the glucose substance are textorotatory. What is the meaning of textorotatory? By using of a monochromatic light passes through the organic substance or sucrose or glucose, those substances rotate in the monochromatic light in clockwise direction. That is called the substance known as a textorotatory substance. So the positive sign indicate the sucrose and glucose molecules are textorotatory substance. Another one, fructose. That fructose molecule meta rotation or optical rotation is minus 92.4 degree. Minus 92.4 degree. The minus sign indicate the fructose molecule is a levorotatory substance. We have already learned in optical rotation or optical isomers. Positive sign indicate the textorotatory substance. Negative sign indicate the levorotatory substance. Plus 60.6 degree is sucrose. In the plus 52.5 degree is the glucose. So both the substances are rotate the plane polarized towards the clockwise direction. That is why this substance called a textorotatory substance. Fructose meta rotation minus 92.4 degree. In the minus sign indicate the levo-rotation because of in the fructose molecule rotate the plane polarized light towards the anti-clockwise direction. That's why fructose otherwise called levo-rotatory substance on hydrolysis because of the sucrose molecule. Sucrose C12H22O11 sucrose molecule, that means called disaccharides, hydrolyzed by sulfuric acid in presence of water molecule to form of glucose C6H12O6 plus C6H12O6. It is a glucose molecule, glucose. It is a fructose molecule. Both compounds are same molecular formula but a different functional group. Both the compounds are existing then what isomers? Functional isomers. Because of both the compounds have same molecular formula but exist in different functional group. That is why these compounds exhibit the functional isomers. Functional isomers. And hydrolyzed by using dilute acid or enzyme, sucrose hydrolyzed to form of glucose and fructose. in the meter rotation or optical rotation of sucrose can be changes from dextro to levo. That's why sucrose otherwise called invert sugar. Sucrose otherwise called invert sugar. Next one, the sucrose molecule can be obtained from glucose compound contain first carbon of OH group can be linked with the fructose compound contain second group of OH group. Second group of OH group. Both compound have functional group involved in then what? Oxide bridge or in the formation of glycosidic linkage. That is why sucrose molecule does not contain aldehyde group or keto group. So, in the sucrose act as a non-reducing sugar because of those molecules which contain aldehyde group easily oxidize to carboxylic acid means those molecules act as a oxidizing agent. Those molecules oxidize then those molecules act as a reducing agent. Those molecules reduce the tolerance reagent to silver mirror or blue precipitate of cupric ion can be reduced to red precipitate of cuprous oxide. It is an oxidation process by using a reducing agent. In sucrose molecule does not contain aldehyde group. The sucrose molecule does not easily oxidize to carboxylic acid. That's why the sucrose molecule acts as a non-reducing sugar. Important point, non-reducing sugar. Okay. The next one, in the lactose, it is a sucrose. Lactose. Lactose also one of the important disaccharides molecules. In the lactose molecule can be obtained from beta galactose can be combined with the beta glucose. Beta galactose can be combined with the beta glucose. What is the meaning of beta galactose? Beta OH group plays it in upward direction means beta. So OH, H, OH, H, OH, H, OH, 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 in OH, H, then hydrogen, the CH2OH. It is a beta D galactose. Beta D galactose. In the OH, H, here, in the OH, H, OH, H, OH, H, H, CH2OH. It is a beta D glucose. Beta D glucose. So beta D galactose can be combined with beta D glucose to form 1,4 glycosidic linkage of 1,4 glycosidic linkage. Sucrose is 1,2 glycosidic linkage. But galactose can be combined with the glucose of lactose means 1,4. How to find out the 1,4? In the OH, hydrogen. Here, in the OH, hydrogen. Then OH, hydrogen. In the bonded with. Listen here. It is a first carbon, anomeric carbon. Is second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Totally 6 carbons are there in glucose. Fourth carbon contains OH group. It is the first carbon of beta D galactose. Second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Fourth carbon contains OH group of beta D glucose can be combined with the first carbon contain OH group of beta D galactose. In this H2O molecules removed. H2O molecules are removed. It is a fourth carbon, it is a first carbon. In this linkage known as a 1,4 beta linkage. Listen, 1,4 beta linkage. So hydrogen bond, hydrogen CH2OH. Here hydrogen, OH, hydrogen, then OH, hydrogen and hydrogen, CH2OH. It is a lactose. In the lactose molecule can be obtained by 2 monosaccharides of beta D galactose can be combined with beta D glucose through oxide bridge of or glycosidic linkage of 1,4 beta compounds. 1,4 beta linkage known as a lactose. In lactose molecule, one compound contains anomeric carbon involved in the formation of glycosidic linkage. Second compound contains anomeric carbon. Second compound contains anomeric carbon do not involved in the formation of glycoside linkage. That is why second compound contain anomeric carbon do not involved. So in this compound can be easily oxidized and act as a reducing agent. So lactose is a reducing disaccharides. Sucrose is a non-reducing disaccharides. Next one, maltose. Sucrose is table sugar. Lactose is milk sugar because of it is found in the what? Milk of mammals. So milk sugar. Then maltose is a malt sugar. Next one, maltose. Maltose is malt sugar. Malt sugar also disaccharides. The malt sugar can be obtained from in the source of malt. Malt means is the important source of sprouting barley. Sprouting barley means வேகமாக வளரக்கூடிய செடி. So sprouting barley is a main source or major source of the maltose. That maltose produce is one kind of enzyme. That enzyme otherwise called alpha amylose. That alpha amylose it is used to digest the starch in plants. Okay. In the maltose can be obtained from combination of two saccharides of same molecule like alpha D glucose. So alpha D glucose. And then hydrogen, OH, hydrogen, OH, hydrogen, and then OH, hydrogen, CH2OH. That compound can be combined with another one moles of same molecule like alpha D. That alpha indicate the first carbon contain OH group facing downward. OH, H, and then OH, H, and then H, CH2OH. Both molecules are same. It is alpha D glucose. It is also alpha D glucose. And then both alpha D glucose molecule linked with each other through glycosidic bond or glycosidic linkage. Hydrogen in the OH, H, in the hydrogen, OH, here OH, H, CH2OH. Another one, hydrogen, OH, in the OH, H, these are bond 1,4 H, CH2OH. It is 1,4 alpha glycosidic linkage. 1,4 alpha glycosidic linkage. It is a structure of maltose. Maltose is always called or commonly called malt sugar. That malt sugar hydrolyzed to give the same molecule of alpha D glucose. So 2 moles of or 2 molecules of alpha D glucose linked through alpha linkage or oxide linkage or glycosidic linkage. Here oxygen atoms are there. Glycosidic linkage to produce the maltose. That maltose molecule first compound contain anomeric carbon. That carbon anomeric carbon involved in the formation of glycosidic bond, glycosidic linkage. Second compound contain anomeric carbon do not involved in the formation of glycosidic bond. That is why that molecule which contain anomeric carbons are there. That anomeric carbon is nothing but aldehyde group carbon. That aldehyde group easily oxidized to carboxylic acid. That's why the molecule acts as a reducing sugar. So lactose and maltose are reducing disaccharides, then sucrose are non-reducing disaccharides. Okay. Next one, polysaccharides. Polysaccharides. In the polysaccharides are polymer of number of monosaccharides linked through oxide bridge. Number of monosaccharides linked through oxide bridge to give polysaccharides. That polysaccharides is the most common compounds of carbohydrates. The polysaccharides are not sugar. That's why polysaccharides are non-sugar. It's a not tasteless substance. In the polysaccharides exist linear compounds as well as branched compounds. Branched chain compounds as well as linear compounds. In the polysaccharides mainly classified into two types. One is a Homo Polysaccharides and one is a Polysaccharides. It is depend upon nature of constituent monosaccharides linked with each other. What is the meaning of Homo Polysaccharides? Those polysaccharides which contain same kind of monosaccharides unit to form of polysaccharides known as Homo Polysaccharides. Homo means same. Example, starch, cellulose, glycogen. It is an example of Homo Polysaccharides. Polysaccharides. The polysaccharides which contain in the different type of monosaccharides linked through oxide bridge. Example, high alluric acid and also heparin. Heparin, high alluric acid is example of polysaccharides. Starch, cellulose, in the glycogen is example of monopolysaccharides. In the starch, next one important one compounds polysaccharides like starch. Starch is one of the important, most abundant polysaccharides. Those molecules which contain number of monosaccharides linked with each other. Number of monosaccharides linked with each other. In the starch molecule, important main source of carbohydrates or main source of energy in plants. So starch molecules. The starch molecules separate into two fractions. One is amylose and one is amylopectin. Amylose. Another one amylopectin. Amylose and amylopectin. Amylose, 20% of amylose, 80% of amylopectin present in starch molecules. In the amylose are water soluble substance. Amylopectins are water insoluble substance. In presence of small drop of iodine, amylose gives the blue color, amylopectin gives the violet color. In drop of iodine, it is an important test to characteristic property of carbohydrates. How to find out the polysaccharides from the monosaccharides? Important characteristic test. In small drop of iodine, in the amylose gives the blue color, in the amylopectin gives the violet color. Okay. In the amylose are in the linear chain polysaccharides. Amylopectins are branched chain polysaccharides. Amylose molecule is a composed of unbranched in the up to 4000 alpha D glucose molecule composed with each others. Alpha D glucose molecule of up to 4000 units is linked with each others. In the amylopectin molecule which contain are composed of branched as well as unbranched molecule up to 10,000 unit of alpha D glucose. 10,000 unit of alpha D glucose linked with each others. In linear chain molecules, in the 8 to 14 glucose unit linked with the linearly chain. Then 24 to 30 unit of then unbranched chain is placed in 1,6 linkage. Amylose is a linear chain polymer. Amylopectin is in the linear as well as a branched chain polymers. Amylose which contain composed of nearly equal to 4000 alpha D glucose unit. Amylopectin molecule which composed of in the linear as well as a branched chain with nearly up to 10,000 unit of alpha D glucose molecules are there. Okay. In the amylose molecule can be linked in 1,4 alpha D glucose unit only. Amylopectin 1,4 alpha D glucose unit linked in linearly. In addition to that, 1,6 linkage present in branched chain. Okay, so amylose and amylopectin. What is the structure of amylose? Number of monosaccharides unit. Number of monosaccharide units. Hydrogen, CH2OH, oxygen, hydrogen, OH, hydrogen, in the OH, hydrogen, OH, hydrogen. It is a one moles of or monosaccharides of alpha D glucose can be combined with another moles of in the hydrogen, OH, hydrogen, OH, hydrogen, in the hydrogen CH2OH. Again combine with another mole because of amylose is a polymer of number of monosaccharides unit linked with each other through hydrogen OH hydrogen here OH hydrogen CH2OH. The two OH molecule can be combined with each other to remove of water molecule to form of 1,4 oxide bridge. It is a 1,4 oxide bridge. Another one, in this two OH group can be combined to form of 1,4 oxide bridge. It is also 1,4 oxide bridge. So in this unit, place it in n times 4,000 units linked with each other to form of amylose. Okay, amylose is a first compound. It is a second compound. It is a third compound. It is a first carbon. It is second carbon. Third carbon. Fourth carbon. Fifth carbon. It is a sixth carbon. Okay. Third carbon, fourth carbon, fifth, sixth carbon. Next one is center unit which contain first carbon, second carbon, third carbon, fourth carbon, fifth carbon. It is a sixth carbon. Sixth carbon of amylose or alpha D glucose. Sixth carbon. Which one is the sixth carbon? That carbon, sixth carbon. Sixth carbon contains OH group, CH2OH group. The CH2OH group can be combined with another molecule of OH, H, then OH, hydrogen, CH2OH. It is 1, 2, 3, 4, 5, 6 carbons are there. Okay, here oxygen atoms are there. Okay. First carbon contain OH group can be combined with the sixth carbon contain OH group. So removal of H2O. In these H2O molecules are removed. Bond, O, bond. In this linkage 1,6 linkage. First aromatic carbon of one compound can be combined with the sixth CH2OH group to form of 1,6 in the what? Alpha glycosyl linkage. Only 1,4 linear chain formation means amylose. In linear chain contain 1,4 glycosyl linkage. In addition to that, 1,6 linkage means is amylopectin. Linear compound amylose. The linear as well as a branched compound is amylopectin. So both compounds are amylose and amylopectins are what? Starch substances, starch compounds. So the starch is separated into two fractions. One is amylose and one is amylopectin. It is one polysaccharides. Next one polysaccharides, cellulose. Cellulose also one of the important polysaccharides. Two types of, already I told you, two types of polysaccharides are there. One is Homo Polysaccharides and one is heteropolysaccharides. Homo Polysaccharides which contain only one kind of monosaccharides unit. Example, starch, amylose, amylopectin. In the cellulose also. In the different kind of monosaccharides unit present in means as heteropolysaccharides. Heteropolysaccharides, in an example, high alluric acid heparin. Monopolysaccharides, example, starch, cellulose, amylose, amylopectin. Cellulose is a composition of beta D glucose, not alpha, beta D glucose. What is the meaning of beta D? In the beta indicate the in an anomeric carbon contain OH group facing upward direction. OH, O, hydrogen, OH, hydrogen here, OH, hydrogen here, in the OH, H, CH2OH. It is a beta D glucose, glucopyranose, beta D glucopyranose. Another molecule can be combined, beta D glucopyranose. Anomeric carbon, OH group facing in upward direction, in the OH, H, in the OH, in the hydrogen, CH2OH here oxygen. Next one, in the beta D glucopyranose. Beta OH facing upward direction, hydrogen OH, H here, OH, H, OH, H, then hydrogen CH2OH. CH2OH. The next one, it is anomeric carbon, first carbon, second carbon, third carbon, fourth carbon. In the fourth carbon contain OH group can be combined with the first carbon contain OH group. These are two OH group contain water molecule is eliminated. So H2O remove, H2O remove, O1, H2O remove. Next one is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Another one compounds. It is a first carbon. So first carbon contain OH group, anomeric OH group, can be combined with the second compound contain a fourth OH group. Fourth carbon have OH group. Oxide bridge. It is 1,4 beta D glucopyranose form. It is also 1,4 beta D pyranose form, glucopyranose form. In this linkage, N moles are there, nearly equal to 20,000 moles are there. It is a structure of cellulose. So what is the purpose of cellulose? Cellulose is a major constituents of plant cell wall. Major constituents of plant cell wall. In the cotton which contain pure cellulose. In the cellulose on hydrolysis to produce the beta D glucose. So cellulose is a polysaccharides of beta D glucose. Beta D glucose. Next one, in the cellulose molecule extensively is used for manufacture of paper, in the cellulose fiber, rayon explosive substance, in the cellulose cotton. The cellulose cotton is nothing but nitrated cellulose ester. Okay. In the human body does not use the cellulose as a food materials because of in our digestive system does not produce necessary amount of enzyme used for the hydrolysis of cellulose. What is the enzyme? Then glycosidase enzyme. Another one cellulose enzyme, glycosidase enzyme does not produced by in our body. That's why cellulose molecule does not use as a food material in our body. Okay. Next one, glycogen. Glycogen also one of the Homo Polysaccharides. Glycogen is used as a storage energy of polysaccharides in carbohydrates. In the glycogen, another one important used for the main source of carbohydrate in animals. It is also found in liver and muscles of animals. That's why in the glycogen, otherwise called animal starch. On hydrolysis of glycogen, it produces the only alpha D glucose and beta D glucose and fructose also, because of it in the molecule is one of the monosaccharides. So in the glycogen molecule on hydrolysis by using of enzyme only produce the alpha D glucose molecule. Okay. The next one, the glycogen in the structurally similar to amylopectin, because of this molecule also exists as a branched chain compounds. Amylopectin is similar to amylopectin. So in glycogen, in the compound which contain 8 to 18 or 8 to 14 units of alpha D glucose opposed with in the 24 to 30 units in branched. In glycogen, 8 to 14 units of alpha D glucose opposed with 24 to 30 units in the branched chain. Excessive amount of glucose in our body exists as a glycogen. Excessive amount of glucose because of in our body produce the number of glucose molecules. So excessive amount of glucose molecule present in our body exists as in the form of glycogens. The last topic, what is the importance of carbohydrate? Importance of carbohydrates. Importance of carbohydrates. First one, in the carbohydrates widely used in plant and animals. Widely used in plant and animals. Plant and animals. Carbohydrates widely distributed in plant and animals is used as a main source of energy and structural polymers. One way. Another one, in the carbohydrates stored in plant as a starch, stored in human body as a glycogen. So, in plant, in the carbohydrates stored in starch, in human body or animals, in the carbohydrates stored in the glycogen. Next one, in the carbohydrates such as cellulose, it is an important constituent of cell wall. It is used to make paper, cotton and cloth, furniture also. The cellulose it is used to make the paper, cotton, cloth and furniture. In the next one, in the cellulose molecules are in the simple sugar. In the simple sugar molecules is used as a main source of energy in our body. The next one, ribose sugar. Ribose. Already we have learned in lower class or 11th standard. It is a familiar topic, DNA and RNA. In the DNA RNA which contain is a composition of adenine, guanine, cytosine, thymine, uracil. In this nitrogen based substance of adenine, guanine, cytosine, thymine, uracil can be combined with phosphoric acid. In addition to that, ribose sugar. Ribose sugar. In the ribose sugar is used in nucleic acid. It means called DNA and RNA. Ribonucleic acid or deoxyribonucleic acid. In the last one, modified carbohydrates. In the modified carbohydrates is used as a in the high aluronate. High aluronate is nothing but is one of the chemical substance is obtained from the heteropolysaccharides. In the glycosaminogluconate, otherwise called glycosaminoglycans. In the glycosaminoglycans or high aluronate can be used as a shock absorber as well as a lubricants. Okay? So okay students, today topic over. Next topic we will meet the next video. Thank you.